when I will dip this wire coated with the silver chloride, here the concentration of Cl minus ion will be equal to the concentration of HCl. We are assuming that almost all the silver ions have reacted. Hello students, welcome to Allen Overseas and welcome back to the very important series that we have started is 45 important topics in 45 days. Okay, that is important for your JEE Main 2024. Right? So, as you know that we have divided this series in 3 parts, 15 topics from physics, 15 from chemistry and 15 from mathematics. This is how we will cover the total 45 topics, right? Okay, and I will be discussing the chemistry part, right? Fine. So, let's start. Let's continue this series with the next topic of chemistry, that is metal-insoluble electrode and KSP. So basically this topic is the combination of ionic equilibrium as well as electrochemistry, right? So fine, let's start our topic with, so we have metal-insoluble salt anion electrode, okay? So what happens in this cell? In this half cell, metal coated with its insoluble salt is in contact with the solution containing the anion of the insoluble salt. Okay, so what is the characteristic of this half cell? First of all, we'll be taking a metal. Okay, suppose we have taken silver. Okay, so we are taking this metal, and on this metal there will be coating of the insoluble salt of the same metal. For example, for silver chloride is the insoluble salt, right? So if we take silver wire, then silver chloride will be coated on that, and now we have to dip that into a solution, into a salt solution, and that salt should be containing the anion which is present in the insoluble salt of metal. For example, here the insoluble salt is AgCl. So now when I will dip this wire coated with the silver chloride in the salt solution, that salt should be containing the Cl minus ion. Okay, the salt should be containing the Cl minus ion, right? For example, we can take KCl. So potassium chloride having the common anion, right? That's why we are calling it as anion electrode. So this anion should be common, right? This is the thing about this. Now how we can represent this cell? So we have silver chloride and Cl minus, right? So if we talk about the representation of the cell when it is acting as a cathode and as anode. Okay, so if it is acting as a cathode, this is a reference electrode, and when it is acting as a cathode, how we can represent it? We know at cathode reduction reactions take place, right? So what will be happening here? AgCl, Ag. Okay, this will be the representation of this cell acting as a cathode. Similarly, this can act as anode also. If it is acting as an anode, the representation will be AgCl, Cl minus, okay, where AgCl are solid, right? Cl minus is aqueous. This is how we can represent it. Now, if we talk about the E cell, the EMF of this half cell, then how we can calculate? Okay, I am writing the EMF for the anode when it is acting as an anode, right? So E cell means E AgCl Cl minus equal to E naught AgCl Cl minus, okay, minus RT upon NF Allen. Now here for this cell we have, when you have the insoluble salt, here the expression will be KSP of this insoluble salt, KSP of the silver chloride divided by concentration of Cl minus ion. Okay, this is how we calculate the EMF of this half cell, right? Now the KSP divided by Cl minus concentration, if we talk about the KSP of AgCl, what is KSP? What is solubility product? Solubility product is solubility product of an insoluble or sparingly soluble salt is basically the multiplication or product of the concentration of ions raised to the power equal to their number. Okay, like suppose in AgCl we have only one Ag plus ion and one Cl minus ion, so the number is 1 1, right? But when you have 2 cations and 3 anions in one salt, then you have to take that number as the power of the anion. Okay, for example, here we have Ag, so the number is 1, so raised to power 1 into Cl minus raised to power 1, right? So this is how we calculate the KSP, right? So now if I will just divide the KSP by concentration of Cl minus ion, what I will get? I will get concentration of Ag plus, right? So in this formula, in place of KSP by Cl minus, what we can write? We can write Ag plus also, right? So that's why if we write that equation here, so AgCl, Cl minus equal to E naught AgCl, Cl minus RT by NF ln. Now in place of this we can place Ag plus, concentration of Ag plus ion. Okay, so when you have got this expression where you have the concentration of Ag plus ion right here, okay, in this term, then this term AgCl, Cl minus, this term can be written as Ag, this can be written as, like here if I write this E AgCl, Cl minus, this can be written as Ag plus. Okay, similarly E naught AgCl, Cl minus, this can be written as E naught of Ag plus. Okay, we can replace these terms only when the KSP by Cl minus, this value is equal to Ag plus concentration. Only then we can replace this, and directly in place of this salt we can directly write Ag to Ag plus. When silver is converting to silver positive, okay, metal is getting oxidized, this term, this format can be used, right? Fine. Now if we talk about the solubility product KSP, what is solubility product KSP? Let's see. Solubility product is defined as the product of concentrations of the ions raised to a power equal to the number of ions given by the dissociation of the electrolyte at a given temperature when the solution is saturated. Okay, so as we have discussed, what is KSP? KSP is the product of concentration of the ions raised to the power equal to their number after dissociation. Suppose here if I take a salt, suppose we have this salt AXBY. So when it will be dissociating, how, what ions we are going to get? XAY plus, suppose, plus YBX minus. Okay, this is how it can dissociate, right? So these are, now the number of ions are X and Y. Number of A ion is X, number of B ion is Y. So now if I want to find out the KSP for this salt, it will be concentration of A, Y plus, okay, raised to the power equal to the number of A ions. So number of A ions are X, so raised to the power X. Okay, similarly concentration of B, concentration of Bx minus raised to the power Y. Okay, so this is the product of concentrations, right? This is how we can find out the KSP. We can take one more example. For example, suppose now we have taken, okay, we can take Ag2, silver oxalate. This is the sparingly soluble salt, right? So when it will decompose, dissociate, we'll get 2 Ag plus ions and 1 oxalate ion, C2O4 2 minus. This is how it will dissociate, right? So the KSP for this salt, will be concentration of Ag plus raised to the power 2, because we have 2 cations, into concentration of oxalate, and this is only 1, so raised to the power 1. This is how we can find out the solubility product. We can write the expression of solubility product for any salt, right? So the power is always equal to the number of ions, okay? It is never equal to the charge. It is always equal to the number of cation as well as number of anion, right? Now, let's see this question related to these concepts. So the question is, a silver wire dipped in 0.1 molar HCl solution saturated with AgCl develops oxidation potential of minus 0.209 volt, and E naught Ag to Ag plus is given as minus 0.799 volt. So the KSP of AgCl in pure water will be, okay. So we have a silver wire that is dipped in 0.1 molar HCl solution, and this is saturated with AgCl, okay, develops a oxidation potential of minus 0.209, right? So this is the metal-insoluble salt electrode, right? Okay, and E naught Ag to Ag plus is given here, and we have to find out the KSP. So first of all, we'll write the equation. So we know this will be acting as a, here the oxidation of silver will be taking place, so this can be written in the form of a anode, okay. Silver dipped in HCl, so silver will get oxidized, right? So this can be written as AgCl, Cl minus, okay. HCl is having Cl minus as the common anion, equal to E naught AgCl, Cl minus, okay, minus, okay, if we take all the values, all the standard values of temperature, and we put the value of R, and we convert the natural log into log, then we know this formula can be written as 0.0591 divided by N, okay, and here log. Now what we have to write, the concentration of Ag plus, we just have seen this formula, right, where the KSP divided by Cl minus is equal to concentration of Ag plus ion, right? And I told you, when the KSP divided by concentration of Cl minus ion, it is equal to Ag plus ion. In this case, these can be represented as Ag to Ag plus, E naught Ag to Ag plus, right? And now minus 0.0591. Now what will be the value of N? What will be the value of N here? Okay, when Ag is converting to Ag plus, when you are dipping the silver wire into the solution, we know this reaction will be taking place. Ag solid will be converting to Ag plus aqueous plus electron. This reaction will be taking place, right? So now we can calculate easily. Okay, we have to calculate the KSP. So first of all, we'll calculate the concentration of Ag plus ion, then we'll calculate the KSP also, right? So AgCl and oxidation potential is given. Okay, here also oxidation is written. So oxidation potential is given. This value is given as minus 0.209 volt. Okay, equal to E naught of oxidation is also given minus 0.799 plus 0.0591 divided by value of N, number of electrons in the reaction is 1, okay, log concentration of Ag plus. This is what we have to calculate, right? If we take it that side, here you will get 0.59 positive, okay, and here this will be negative actually. Here we have the negative sign, right? So minus 0.059 log concentration of Ag plus ion. So after solving this, what we are going to get, let's take this on that side. So we'll get 0.59 negative divided by 0.059 equal to log concentration of Ag plus ion, this will be minus 10 concentration of Ag plus ion. So from this we are getting concentration of Ag plus ion equal to 10 raised to power minus 10. Okay, this will be the value of concentration of silver ion, right? Now we have to calculate the KSP. So now it becomes very simple. We know KSP is equal to, KSP for AgCl is equal to concentration of Ag plus ion into concentration of Cl minus ions, right? So concentration of Ag plus ion that we have got 10 raised to the power minus 10 molar into concentration of Cl minus ion. Okay, so now here the concentration of Cl minus ion will be equal to the concentration of HCl, right? Because all the chloride ions is coming from this HCl. So 0.1 molar means 10 raised to power minus 1. So 10 raised to power minus 1 molar. So we'll get 10 raised to the power minus 11. So the value of KSP for the AgCl will be 10 raised to the power minus 11, and that is given in the option B. So that's why option B will be the right answer, right? Now let's try to solve one more question related to this. So this is the question. It is saying that the EMF of the following cell is 0.22 volt. Okay, this cell is given here. The first part is the metal-insoluble salt electrode, right? And here this is the hydrogen electrode. Okay. Okay, now which of the following will decrease the EMF of the cell? So option A is saying that increasing pressure of hydrogen gas from 1 atm to 2 atm, will it decrease the EMF of cell or will increase? We have to check. Increasing Cl minus concentration in anodic compartment, increasing H plus concentration in cathodic compartment, and decreasing KCl concentration in anodic compartment. Okay. So first of all, we have to write the equation to find out the EMF of this cell. Then we will be able to find it out. So let's see. This is acting as an anode. This is the cathode, right? So what we can write here? If I write the reaction for the anode, silver is getting oxidized. So we can say what reaction will be taking place? Ag solid reacting with Cl minus and giving AgCl solid plus electron. Okay, this is taking place at anode. This is anodic reaction, right? Oxidation of silver. And for the cathode, what will be happening? Okay, this is losing one electron. So here we have H plus ion. So H plus ion will be accepting the electron and will be converted to hydrogen gas 1/2, right? And this is taking place at cathode. This is reduction, right? So overall cell reaction will be Ag solid plus Cl minus, right, plus H plus ion and giving AgCl solid plus half H2 gas. This is the overall cell reaction. Now for this reaction, if we write the expression to find out the EMF of cell, what will be the expression? We know E cell will be equal to E naught cell minus 0.0591 if we take the standard condition divided by N. Okay. Now log, at the product side you have hydrogen gas, so it will be pressure of hydrogen gas raised to the power 1/2 divided by concentration of H plus ion and concentration of Cl minus ion. Okay, this will be the expression for the EMF of cell, right? So now let's check the options again. So increasing pressure of hydrogen gas from 1 atmosphere to 2 atmosphere. So if we increase the pressure, you can see that this whole term is with negative sign. So when we will increase the pressure, the negative value will increase and EMF of the cell will decrease. Okay, so by first option we can say the EMF of cell will decrease. So A option will be correct for this question because we have to find that factor which is decreasing the EMF of cell, right? So A will be correct. Let's see the second one. Increasing Cl minus concentration in anodic compartment. Yes, Cl minus is present in the anodic compartment, and if you will increase the concentration, so increasing the concentration of Cl minus ion So this negative value will decrease and EMF of the cell will increase. So in B option, EMF increases. EMF of the cell increases. So that's why this cannot be the right answer, because we have to find that factor which is decreasing the EMF, right? So option C, increasing H plus ion concentration in cathodic compartment. Yes, H plus is present in cathodic compartment, and yes, if you will increase the concentration, again the negative value will decrease. So EMF of the cell will increase. So by this factor also EMF increases. So that's why C is also incorrect for the question. Now the last D option, decreasing KCl concentration in anodic compartment. Decreasing KCl concentration means Cl minus ion will decrease. Cl minus concentration decreases. Okay, Cl minus concentration will decrease. So this whole value will increase. This whole value will increase. Negative value increase means EMF of the cell will decrease, right? So by D option also, the EMF of the cell will decrease. So that's why here option A and option D, both options are correct. Fine. Now let's try to solve one more question that is related to the solubility product, right? So we have 0.10 mole sample of AgNO3 silver nitrate, okay, dissolved in 1 liter of 2 molar ammonia. So is it possible to form AgCl solid in the solution by adding 0.010 mole of NaCl, right? So basically what we are doing here, we have 0.10 mole of silver nitrate and that is added or dissolved in 2 molar ammonia, right? And then we have to find out that if in this same solution, if we add 0.010 mole of NaCl, then is it possible that the silver chloride precipitate will be formed, right? Ksp of AgCl is given and Kf formation is given for AgNH3 whole twice. This complex formation constant is given here 1.6 into 10 to the power 7. So how we are going to solve this? First of all, we have to write the equation. We know in silver nitrates, the silver ions will be present, Ag plus. So silver ions, they will react with ammonia and will form the complex AgNH3 whole twice positive. This complex will be formed by their reaction, right? Now I have 0. At T equal to 0, if I talk about it, I have 0.10 mole of AgNO3 and we are adding this in 1 liter solution of ammonia. So volume will be 1 liter. So this can be written as molar also, mole per liter. So 0.10 molar. Ammonia is already 2 molar given in the question, right? This will be 0 at T equal to 0. After some time, we know the silver ions will react with ammonia and will form the complex. So if we assume that almost all the silver ions have reacted with ammonia. So 0.10 approximately all have reacted. So suppose very small amount, X amount of silver ions is left. Suppose we are assuming that almost all the silver ions have reacted, have complexed with ammonia and only a very small amount X is left, right? And here if almost all is reacting, so for ammonia it will be 2.00 minus. Okay, for 1 mole, 2 mole of ammonia are reacting. So for 0.10 moles, how many moles of ammonia will be reacting? Twice, that is 0.20. Okay, so this will be 1.80 molar ammonia will be left, right? Now how much this complex will be formed? For 1 mole of silver, 1 mole of complex. So for 0.10 mole, it will be 0.10 molar complex, right? So this is after the reaction. So we have X amount of Ag plus. For this reaction, if we write the Kf expression, okay, Kf expression, then it will be concentration of Ag NH3 whole twice positive divided by concentration of Ag plus into concentration of ammonia raised to the power 2, right? Now, this value is equal to 0.10 divided by Concentration of Ag plus which is left, we have considered it to be X. So this is X into concentration of ammonia 1.80 square. Okay. And the value of Kf is also given in the question, that is 1.6 into 10 raised to power 7. Okay. Now we have to solve this equation and find out the value of X. So what will be the value of X? The value of X from this equation that you will be getting is approximately 1.93 into 10 raised to the power minus 9. Okay. This is the concentration of Ag plus ion. This is the concentration of Ag plus ion which is left, or we can say unreacted, which is not forming the complex with the ammonia, right? So this is the Ag plus ion which is left after the reaction. Okay. So now when you are adding the NaCl, how much moles you are adding? We know the concentration of Cl minus ion will be equal to the concentration of NaCl. Okay, so this will be 0.010 means 10 raised to the power minus 2 molar. Okay, again the volume is 1 liter. So 10 raised to the power minus 2 molar concentration. So now this is the Ag plus left. So now if I calculate the ionic product of Ag plus and Cl minus ion, the ionic product of Ag plus and Cl minus ion, so that ionic product will be 1.93 into 10 raised to the power minus 9 molar into Cl minus ion 10 raised to the power minus 2. So we are getting 1.93 into 10 raised to the power minus 11. This is the ionic product for AgCl, right? And the KSP of AgCl is given in the question. KSP of AgCl is given in the question, that is 1.8 into 10 raised to the power minus 10. Okay. So this ionic product is less as compared to KSP. This is the ionic product. This is the ionic product. So when ionic product, we know when ionic product is less as compared to KSP, then in such case no precipitation takes place. No PPT, no precipitation will be taking place. That means in this question, in this situation, there will be no precipitate of AgCl, right? So what will be the answer of this question? The answer of this question will be that there will be no precipitate of AgCl in this solution, right? So that's it from my side on this topic. We'll be continuing this series, so stay tuned with us. And don't forget to watch the complete series. The link for the playlist is given in the description. So do watch the series and do share your suggestions and queries in the comment box below. We will surely revert you back. So take care. Thank you.